Reflex 10, and so on and so forth. So you have to do your own research. Don't rely 100% on one person explaining to you how it should work. I'm just giving you a bit of confidence. You've got the internet, you've got Wikipedia, you've got people like me doing ham radio channels. You can ask and poll around, because every problem you're going to have, it's probably unique, okay? It'll be unique. You put an inverted L up. Now, we all know that an inverted L on 80 meters normally gives you about 50 ohms, all right, depending on the ground. About. I put one up at the farm, and I was getting 112 ohms. Why is that? I had a unique situation. I had all this metal fencing. Yet other people have put an inverted L up with metal fencing around and about, and haven't had a bloody problem at all. So what I'm saying is, a lot of the problems we have are unique to the planet, to the where we are. That's the fun, isn't it, of RF, is exploring and trying to work out what's going on. In the main, everything just works. But when we get a little problem and you ask around, sometimes nobody blooming knows. So by all means, ask your Elmer. But if he honestly doesn't know, and get it out of him. Get it out of him. Yeah? Do you know or not? No, I don't. Right, easy. Next video is coming up here. My rant for the day. Have a jolly good day. Thanks for tuning up, and I will see you next time. Bye for now. And a very good day, everybody. Hopefully we are live. In the chair tonight, we've got John NJ4Z. John, have you noticed that on my live streams now, in the UK, we say Z, and in the US, they say Z, but I have started to say Z.
Oh, no. So, I use Z, so I guess we're just reversing it.
Really amazing. Yep. Okay, fine. I'm just going to ask the folks in the live chat whether the balance of our two audios is roughly about right. This isn't the BBC. We're just having a telephone chat on StreamYard here, and you kind guys have agreed to call in. So I'll have a look in a minute and have a look at the live chat, which we've got over here. I see we've got just welcome some of the spanners. Tom and Jim and a few other people, Duncan as well. So I'll just flick to this camera here because I just wanted to cover through what we're going to be doing tonight. Well, it's tonight anyway in the UK. Local time, John, mid-afternoon for you, is it?
4 o'clock.
4 o'clock, okay. Well, we're 9 o'clock here in the US. Sounds good, says Tom, for both.
Fantastic.
John and we're going to build up from a single vertical all the way through to a parasitic array, a phased array. Then we're going to move into 3 elements, and that will be either 3 in a row, but there's a triangular element as well that I want John and I to talk about, because I've got a video you can watch after this where John explains how he built a triangular array for me, actually, and I feel very guilty, John. I still haven't installed that, but one of the reasons we're having this conversation is I'm getting near that point now. And so we'll do parasitic arrays, then we'll do phasing harnesses and where velocity factor comes in and things like that. Then about 2 years ago, I was talking to Tom about a pair of phased arrays, which somebody, I think it was either CQ Worldwide, John, or CQWPX, somebody made a pair of phased arrays and phased them together, right? And they nicknamed it the flamethrower. So we'll cover that as well. And then we'll cover a fantasy project of mine called the double flamethrower. All right. And then I've got one super fantasy antenna, which would require 24 DX commanders. Right. But anyway, we'll come to that in a minute. And I've just realized after this, John, that I am actually starting to overheat with the lights on and my pullover on. So I'm going to ask you a question. You can shoot. I'll take my headphones off, take this off, and then I'll be back to normal again.
Okay.
So now you have just come back from, what is the island called?
St. John, USVI.
St. John, yeah. Mm-hmm. Which is the US Virgin Islands. That's what they call it.
Correct, yeah.
Okay. But you were running that. Was it actually a Parks on the Air event as well?
It was, yeah. So I rented the house to be purposely in the park, and we ran Parks on the Air from the park number is Kilo 0066 Virgin Island National Park. I ran in the park 4 years ago and did some on the beach activations. This time the house was located in the park, so I ran from the house. DX Commander Expedition, which is the ramped up version of what I took in 2018, which was the prototype that you had just started to introduce.
I can't believe that.
We got it running, and we ran close to 3,000, right at 3,000 contacts for the thing. I can't say enough for the antenna. It worked great. Of course, vertical near saltwater, you know what that means. You get a little bit of push off of that. So it was just fantastic, brother.
Yeah, it's fantastic. So, okay, well, let's start with a single vertical, if you like. Now, you and I both, by the way, I kind of trust modeling, software modeling, from the point of view of roughly what it's probably going to give us on a far field plot. All right, roughly. Okay, so I don't want to go down this loop of some people go, oh yeah, but it's not very accurate and whatever else. I believe the mathematics was the moment method. I think someone discovered it maybe in the 50s, John. You might know more about that than I do. But the mathematics exist. So if you can interpret the mathematics and stick it in a piece of software, then you can end up with a reasonable plot. Now, I happen to have Ready to Rock here. I've got a lot of stuff ready to rock, actually. But if I press this button, I've got the double fantasy antenna ready here. So let me get rid of that.
Yeah, we don't want to show that till the end.
No, it's fine. So you can quite easily build in N1MM. I'll just build an antenna at 10.2 meters high, and I'll wire one base. In other words, I'm going to put a red dot at the bottom of this, which is our coax. And I've put to ground. I've got about 32 radials at the farm. So that's kind of roughly how I just leave it like that. And I hit the start button, and it's telling me it's on the wrong frequency because I want about 7.2 megahertz. So, but this just gives us a baseline, you see. The baseline, I'm coming down to about 5 degrees, and it's giving us a number of minus 4.6. Now, John, you understand this baseline that I like to use of minus 5 degrees off the horizon. You probably get it. A lot of people don't get it. They say, yeah, but what happens if my DX is coming in at 10 degrees or 3 degrees? But we need a baseline somewhere, don't we, where we can go, okay, well, let's just
compare things. Yeah.
So when you build another antenna in software, you can go, oh, what was the other one we built? 5 degrees off the horizon, which is a fairly safe bet for the 4,000 mile, reasonable skip from, that would be from your place to Europe, a good somewhere before 5, 6, 7 degrees. So that's fine. So our vertical, which is, we don't need anything other than a bit of 50 ohm coax, and we'll get a better than SWR. What do you reckon, John? 1.5?
1.5, somewhere in that neighborhood. You get 35 ohms for a
perfection.
Yeah, perfect. Yeah, for 35 ohms is what you're going to be looking at. So somewhere in there, you'll be fine. Yeah.
And with a bit of coax run and whatever else, you're even a radio without an ATU would be fine with that, wouldn't it?
Sure. Yeah, no problems at all.
And when you went to St. John, then were you running any sort of ATU?
No, I didn't run the ATU at all. I have an FTDX10, so it has an internal ATU. But I said, no, we didn't need it. I mean,
pointless, right?
Everything was. I think the worst band I had was 40, and 40 was at about 1.5, 1.6. I tuned it down to get 15 a little better.
Okay.
To make sure I had 15 dead on, because I with the sun cycle I wanted to work 15 a bit. So
sure.
But yeah, everything was between 1.2 and 1.7 at the worst case.
Okay, worst, yeah, okay. All right. So that is a single vertical, which we all know and love. And I don't know about you, John, but years ago I tried a couple of verticals. I just couldn't get them to work. And I don't know why. And I think maybe I was in a housing estate here, and I am using it on receive only and trying to gauge what my transmit is. And if you're in a housing estate, it's the wrong thing to do. So, but if you've got a couple of runs of coax out to your backyard and you've got a dipole and a vertical and you've got a bit of DX, you go, do you mind if I just compare the two? And I think you'll find he'll say, oh, yeah, you're an S point better or whatever. Right, single vertical. So this masterclass with John and I is about gain. So gain gives you, normally, you take your bubble of RF, and if you're going to squash it over there, it means you're going to lose somewhere, don't you? All right? We call that front to back ratio. John, do you find front to back important in modern running pile-ups and parks on the air? Not really, I was thought.
No, because you want to take as many as you can, so you're listening for all over the place. Now, if you're working DX and you're chasing DX, yeah, you want that front to back so you can clear out anybody who's coming in behind you that might be interfering with the DX signal coming in.
Yeah.
You know, for me in a contest, I would much rather run an omnidirectional antenna than a directional antenna as a hunt and pounce kind of guy. If you're the calling guy in a contest, then you definitely want a directional antenna so you can focus it where you want it, and it's going to knock down everything coming off the backside that you don't care about.
Yeah. Do you know that's funny because on the Sunday morning, just before I started streaming on 10 meters with my big Evolution hybrid thing, I scored with Peru, then China, South Africa, and then into the US. I couldn't have done that with a Yagi.
Nope.
All within 10 minutes. I wouldn't have even known that the South African existed because he would have been off the side, which is probably about the worst. Right, ladies and gentlemen, gain. Okay, so we're going to go back to our little thing here, and we're going to build a little parasitic. Okay, we're going to put the parasitic behind this one. I can't remember. I think I just put roughly 8.5 meters behind. Have you ever done a parasitic?
Yeah,
John?
I've done a couple different parasitics, 2-element and 3-element. More experience with the 2 than the 3.
Yeah.
But yeah, 2s and 3s, 3 triangle too, but we'll talk about that in a bit.
Okay. I'm not worried about the SWR and impedance. I could muck around. I'm just giving people a roughly idea, okay? Let's just head at 5 degrees of horizon. So whereas moments ago we had minus, just under -5, slightly better than -5, I think, John, it was, is at 5 degrees off horizon now. This is saying that all around here, and I'm reading these numbers up here, we're about 4.5 dB better. Now, you've run a 2-element array, I think, in the past, haven't you?
Right.
Does it feel like 4 or 5 dB better when you're actually running it?
On the receive side, yes, it does. And the front to back helps a whole lot because you're clearing out a lot of the stuff you don't want to hear. But and you'll hear people, and you know, it's hard to tell because people give you all kinds. You know, in a contest, you're 5'9", 5'9", 5'9". It doesn't matter.
Yeah.
But if you're just talking to somebody and you run, you know, a 5'7" to somebody, and then the next time you come to them, you run a parasitic and you're 5'9" plus, then you know you're gaining something. And you know, every 3 dB of gain is doubling that signal strength. So, but it's half an S unit. So
yeah.
So you need 6 dB a gain to gain an S unit. So if you go from S8 to S9, it's 6 dB of change.
Yeah, indeed. Yep. Now, it's funny enough, there's a couple of people who called me on the contest, and I could nearly squeeze the call sign out. I literally 2 or 3 times in that contest, I wanted that extra 3 dB. Do you know what I mean? I could have really done with it, either on their end or my end.
When you modeled that antenna, how much gain did it give you being elevated like that?
The big tall one?
Yeah. The 10.
2.5 degrees, just under 3 dB.
Wow. Okay. Yeah, because I tell you what, I heard you in St. John, and you were just absolutely smoking down there.
Really?
My little 100-watt PP shooter wasn't getting up there, so I couldn't break the pile up you had.
So to confirm, ladies and gentlemen, if you can see this, we've got our main coax coming up to a vertical, and which I'll do in a different colour. We have vertical here, and we got some radials. Radials we'll cover maybe later or another day. This element, this element here isn't connected to the radials because we've got an SO239 with the center and with that coax, and that the center of the coax is going up. The element and the braid is effectively connected to the radials. Now, what we've done here is next door to it, I've modelled it roughly 8.5 meters. In fact, Rowley has done some good tests. 8.5, 8.7 meters he found on 40 meters. So half that on 20. So we're going about 8.5 meters that way, and I'm just building another one. But I am physically grounding these elements to that. There's a physical connection between the driven element and the radials. Is that how you do it, John?
Exactly. For parasitic, yeah, that's exactly how you want to do it. You basically make a reflector out of that back element, and it pushes the RF in the direction of the opposite the reflector.
Indeed. And I reckon about 5%, give or take, longer on this one. Well, if that's X, we'll call this one Y. 5% longer, then we end up with, and I'll press this button here. So in this drawing, the parasitic reflector would be on the right-hand side over here, and our going over there.
And it's funny, if you play with the distance between the two elements, it'll change that pattern quite a bit. Now, it does change your SWR as well, so you have to be careful with that. But you can actually stretch that pattern to
as
give
far
it
as you dare.
Yeah.
Because, ladies and gentlemen, sometimes the three things we're after, front to back, gain, and SWR, you can't have it all.
two you can have, three you cannot.
You just can't have them all.
Exactly.
So you get a fantastic front to back, fantastic gain, and SWR, which is off the scale. You've got to remember, this is a coax-fed world we're living in tonight. Okay, good. All right, so that's fine. Now, the other thing we can do is, I'll just go back to this screen here, is that at the front, so if we've got 8.5 meters there, we could come to about here, we could build another one, and again, this one would be about 5% less. And I have a pre-prepared one, which we can quickly show you what the...
Always prepared.
Yeah, if not, we'll just draw it. Reopen. I've called it a Yagi, but this looks like this. It doesn't look, but the one on the right-hand side would be slightly taller than the one on the left-hand side. And this happens to be tuned on or about 7.1. Hopefully you can see this okay. If I go to the far field plot, whereas we were at about 0 dB gain, now we're at 1.1. So maybe, just maybe, we might have gained 1 dB. Yep. Just maybe. Now, have you had much experience with 3 and 2? Or did you only build a 3 once?
I've only built a 3. The parasitic only, in a Yagi configuration, only one time.
Yeah.
And it worked really well. I couldn't compare it to the 2. So, build them at a different time. But
I mean, the pattern looks nicer from its front to back.
Yep, sure does.
And in fact, we can press a button here and do some cool stuff.
You can see it flattened out that back where the other one was kind of bubbled out the back a little bit. This one's flattened it off.
Yes.
A bunch.
So there you go.
Yep.
Now, John, can you just talk through us what people call a 3 dB gain pattern?
Okay, so when you talk about beam width for a Yagi or any kind of directional antenna, you talk about your highest point of gain as being the center point, and then you go 3 dB of loss on either side. So you take that measurement. So if we have at 0 degrees, we've got 3 dB of gain, and you sweep back out where it goes to 0 dB of gain, whatever the difference in the angle there is. So let's say it's 15 degrees. then you would have 15 degrees on the other side of that. So your 3 dB band beam width would be a total of 30 degrees. Now this one's probably closer to probably what, 90,
-2. Where's -2 here? 1, 2, 3, 4, 5. Yeah, okay, yeah, like nearly 120 degrees on that one.
120 degrees. Okay.
3 dB. So, in other words, in the UK, if I face that west, roughly, then the north part of that curve would get from Seattle down to Florida. The middle would be getting Mexico, and then the southern part, I would be getting Brazil, Chile, Falklands, and on 40 meters, long path, New Zealand and Australia. Okay, so now there's a different way of cooking this. So let's go back to here. We'll draw this time 2 verticals with appropriate number, and they're matched this time, aren't they, John?
Same distance, same length.
That's it. So we've got 2 pieces of coax. Well, I'll tell you what, John, I'll give you something to talk about. I'll draw and you can chat.
Sure.
Is that how we've got a piece of coax coming up here, right? To, let's just say, to start with, John, let's just start with a T-piece and we'll feed them both to start with. So we'd have a T-piece here, wouldn't we?
Yep.
And then, does it matter how much coax we've got to each one?
So that's a loaded question. Some people tell you it doesn't matter.
Yeah.
But in the reality, when you look at the physics of it, you really do want to optimize the antenna. You want to have a specific length of coax there. Okay. From the T-piece to the driven element on both of those. Okay. So I think it was Alan Chrisman. I think that's the correct name, first name. But Chrisman method, he uses 280 to 84 degrees pieces of coax to feed the 2 verticals. And then he loops in a 71 degree piece.
Right.
That does the phasing.
And these bits here, if I've got a different color, would that be, I mean, because traditionally, if you were doing a phasing harness between the 2, these would be, what, 75 ohm?
Yeah, 75 ohm. You can do them with 50 ohm. It just changes the figure just a little bit.
Okay.
Yep.
So if we've got, we'll do velocity factor in a minute, but effectively, if you've got a quarter of a wavelength of 75 ohm to this one, and a quarter of wavelength of coax to this one at 75 ohm, and these are both 50-ish, we should roughly end up with about 50 ohms coming down here.
Exactly.
Give or take. Right.
It
Okay.
balances the antennas out.
Right. So is there any advantage of just doing that? And, well, take it from me, I think I might have one pre-prepared. Doesn't really matter if I don't. You almost get, it depends who you read, Array Solutions say up to 3 dB, but effectively what's happening is your gain is going through the middle, all right? And there's not a lot. It's not quite omnidirectional, but you're getting maybe 1.5 dB extra gain through the middle, all right?
Sure.
Now then, let's just talk conceptually. Is so what we can do then, John, or maybe you can tell them, if we delayed this one, we can add another piece of coax to it, can't we?
Sure. And you basically do it with a relay. You loop in another piece of coax and you switch between which direction you want it to go. Now it's counterintuitive, right? So if I put the delay in to your right-hand side, Callum, then the RF is going to go to that right-hand side. Okay. Because I've got direct connection to the left-hand side, and it delays the signal going to the right-hand side. So when that left-hand side hits the right-hand side, they go in phase and they take off in that direction.
Right. So you got the wigglies effectively come up. Let's just say we've got no relays or anything. We've just got a T-piece here. And then effectively we've got a longer piece of coax sitting in here.
Right.
And somebody did some experiments, and it was about 70 degrees. Now let's talk what the hell 70, what it actually means, John. I think it'd be a good idea.
Yep.
So this is all about sine wave, isn't it?
Yep. So you have your sine wave and you draw it through the sine wave. So in the center, you're at 90 degrees, right? Or I'm sorry, at 180 degrees. You have 90 at the peak, 180 in the center. So 90 there. Yep. And then 180 in the center. And then you go 270 and 360. So, and that gives you your full wavelength of one. So if you talk about.
So yeah, if this was on 40 meters now,
Yep.
and you just put a carrier out, it's not, it's about 42 meters, but the distance from there to there is, I don't know, whatever, 41.5 meters or something, right?
Yep.
So, right. So when somebody has done some experiments and has said, what you do, Callum, is find me a 70